And just when you thought factoring was over, it is not. So now we're going to factor the polynomial completely, and then we're going to solve for the equation, okay? So same thing here. I see a difference of squares. This is going to end up being, so this is going to be 0, or we'll do it this way. We'll do 6r. Oh, I can pull an r out of both of these first of all. That makes my life super easy if I do that. Then I see a difference of squares. Okay, gonna fill in my form. My a is my 6r, my b is my 1. Okay, then we have to set each of these equal to 0. So this is r equals 0, 6r minus 1 equals 0, and 6r plus 1 equals 0, okay? So r minus, this would be r equals 0, this would be r equals 1/6, and this would be r equals negative 1/6. And those are all your solutions, all your real solutions. All right, we're gonna do one more of these together, and then we're gonna go ahead and move on. So, let's see, do I want to do, I totally forgot which one I was gonna do. Oh, here it is. Let's go ahead and do this one. Okay, so I am going to start by dividing m out, or what we can do is just rearrange some things. Okay, I see that we have a 3 in common. And I also noticed that we have an m squared in common. So let me change this to a 4 real quick, because I forgot to write the 4, I wrote m squared. Okay, so this is going to be 3m squared, 25m to the 4th minus 1. And again, that's my difference of squares, so I'm going to go ahead and factor it over on this side, on the left side. So I'm going to just fill it in here real quick. And then this is supposed to be squared. Okay, so we have 25m squared minus 1. Well, that's the same thing as 5m squared minus 1 squared, which is 5m plus 1, 5m minus 1, okay? We set all these factors equal to 0 so that we have 3m squared equals 0, 5m plus 1 equals 0, and 5m minus 1, and then you equal 0, and then all you have to do is solve for m. So for this one, you're going to get m equals 0, right? This one, you're going to have m equals negative 1/5. This one is m equals 1/5, and you can solve for m. Those are those solving for a single variable type of deals. Okay? All right. Next up on our list is find the zeros of the function. So I'm going to use rational root theorem here. So I'm going to put that up at the top. Okay. And rational root theorem is going to go ahead and be, you take your p, oops, this is going to be my q, so there's a 1 here, my q, and this has a plus, this has a plus 0. I don't like that. I'm going to choose my last term here. I'm going to choose negative 12 and see if that works out for me. So as my p. So we're going to take 12 over 1, and we're going to write all the factors of 12. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Not 5, but 6 works. 7, no. 8, no. 9, no. 10, 11, 12 also works. All over, the only factor of 1 is 1. So my possible roots are going to be plus or minus 1, plus or minus, because if I'm dividing 1 by all of these, like I'm doing 1 over 1, 2 over 1, 6 over 1, that kind of stuff. So it's plus or minus 1, 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12, right? Back in my day, we had to try all of these. And I don't want to try all of them. So we're going to look at our graph on Desmos, and I see that I have 0, 0 as a solution here. And I have another x-intercept at 4, 0, and I have another x-intercept at -3, 0. I don't have any more than that, just those three. So I'm going to go ahead and choose 0, -3, and 4. So there's no 0 here, that's totally okay though. So I'm going to do -3 and 4. Okay. I'm going to open up my synthetic division here, and we're going to go ahead and factor this the best that we can. So I'm going to test -3. So we have 1, -1, -12. I don't think I'm going to need placeholders. I'm going to drop my 1 down, -3, -4, +12. That is a factor. Okay. So I'm going to draw my axis here so I can work on my axis while I am kind of multitasking here. And I'm going to plot -3, so -1, 2, 3. Okay? Now I'm going to take this here. Okay? So this has become, or this originally was x to the 4th minus x to the 3rd minus 12x squared. We've divided an x out. We divided an x equals -3. And now I'm going to divide out. We saw that 4 was another one of ours. So I'm going to put my 4 here. But this original piece, I don't know if this makes sense, but this piece here, if I wrote it out as a polynomial, this would be x to the 3rd, because I divided by an x, minus 4x squared. Now you can totally hand factor that. What I am doing though is I'm showing you that with synthetic division, I can just keep factoring the polynomial. Because it's like if I have 18, right? I say, well, that's divisible by 2, right? And that's 9. And I say, okay, well, 9, if I keep wanting to factor it, is divisible by 3. And that's 3, yeah? So that's what I'm doing, is I'm saying, okay, well, this here, yeah? And then 3 is the only factor of 1, that is. Or 3 is not the only factor of 1. That was not a statement that should have ever been made. I was saying that 1 is the only factor of 3 besides itself. So that's what makes it prime. So we get 1 and then 4 and 0. Now, once we're done pulling that out, this would be x squared, right? And we don't have to add anything to it. We don't have a remainder, so it's just x squared, right? So I know now that my original polynomial, x to the 4th minus x to the 3rd minus 12x squared, is equal to x squared times x to the 3rd minus 4x squared. Okay? And that comes from here. Let me change my color, here and here. Okay? Well, I can still hand factor if I'd like, right? Wait, I don't think that made quite a lot of sense. Hold on. I think I skipped a step here. This would be x to the 5th. Yeah, that was wrong. I apologize. That was such a wrong statement. Whoop. Please disregard what I just said. This is x cubed minus 4x squared. You're taking this piece here, right? And you're taking these factors. That's why that didn't work out in my brain. So this is x plus 3 and x minus 4 and x squared. And I'll show you how I got x minus x plus 3 and x minus 4. This is because we have x equals -3. And if I add it to the other side, I get my factor. Same thing here. X equals -4, or x equals 4, is x minus 4 equals 0. Okay? So if you set all these factors equal to 0, you'll notice that you got -3 and 4, And the one that we haven't evaluated yet is x squared. So we're going to divide that by x, and we get x equals 0. Okay, so our x-intercepts are going to be 0, 0, 4, 1, 2, 3, 4, negative 3. Okay, I notice that my a value is greater than 0. Okay, I notice that it is an even degree. Okay, so I know that it's going to look something like this. Okay, so end behavior wise, right? One other thing I do want to talk about too is, well, how come 0, 0 doesn't go through the x-axis, right? How come that one just kind of bounces off? Well, that one is called multiplicity. So x equals 0 with a multiplicity of 2. So if it has that even multiplicity of 2, right, because that can be written as x times x, see there's 2 of them, right? That means that it's just going to bounce, okay? So my final graph is going to look something like this. Remember, we're curve sketching. So even though you have this curve underneath here and you know what the max and mins are going to look like, right? You know that we have a minimum here and we have an even bigger minimum here, right? We're just sketching it. So it says find the zeros, sketch a graph of the function, okay? Let's go ahead and try it over here. So I'm going to use rational root theorem, and I know that my p is going to be, we'll say 9, and this is my 4, which is 4. Okay. So we're going to have 9 over 4. Let me change this up, my notation here. So 9, 4. The factors of 9 are plus or minus 1. 2 doesn't work, 3 works. And then no other number is going to work but 9. 9 is one of my favorite numbers besides 7. I like 7 because it's prime. And it's 7. It's just a cool number, you know? Factors of 4 are plus or minus 1. Or we don't have to do plus or minus on the bottom. It doesn't really matter. 1, 2, 4. And now I think you'll be able to see where I pull my factors from for my possible roots. Sorry, not factors, where I pull all my possible roots from. Okay? So my possible roots are going to be plus or minus 1, plus or minus 3, plus or minus 9. Okay? Plus or minus 1/2, plus or minus 3 over 2, and then plus or minus 9 over 2. Plus or minus 1/4, plus or minus 3/4, plus or minus 9. Okay, again, I've printed this Desmos thing, kind of helped me out a little bit. I've got a 0 here, and I've got one here, which looks to be about 1.5, which seems a lot like 3 over 2. So this is going to be 3 over 2, comma 0, and this one is going to be 0, 0. Okay, I already noticed that this is probably going to have some multiplicity with it because this bounces, so I have to look out for that. Okay, so I'm going to start with, there's a couple ways we can do this. Well, I know that 0 works, right? 0 is always an option, even though I don't list it here. 0 is always an option to try. 0 is always a good idea to try, okay? Even though it's not listed, right? So I'm going to do 0. Otherwise, I would suggest you do long division, and I don't think anybody wants to do the long division right now. So if I do -4, 12, -9, I don't need a placeholder yet, so it's okay. So I'm going to do -4, 0, 12, 0, -9. I am going to put a placeholder for 0 because this would be plus 0, okay? And that would be 0, 0. Okay, I'm also going to do the long division version to kind of show you what that's going to look like if we choose to do it another way, but I'm going to resize this first. Okay, so that means that if I had an x to the third, right, this would be negative 4x squared plus 12x minus 9, right, times, and if we write x equals 0, that's just times x, yeah? So I'm going to rewrite that here. So my original polynomial, we're going to call this f of x, because that's what it was called earlier, is equal to x times negative 4x squared plus 12x minus 9. Okay? I'm going to go ahead and factor what's on the inside, and you will get f of x equals x times 2x minus 3 and negative 2x minus, or plus 3, right? You can also, if you choose, rewrite it like this. That is left up for you to decide if these are the same thing. So I give you a hint because I wrote the full thing, and now I'm going to erase this part and square it, okay? So then you would set each of these equal to 0, so x equals 0, of course, and we saw that with the synthetic division. We also know that 0 is equal to 2x minus 3 squared, so that's going to be 0 equals 3 over 2 with a multiplicity of 2. So it's going to, but truly is very helpful here. I know that I have an odd degree, right? So my degree is odd. Okay, and I also see that I have a negative leading coefficient. So my leading coefficient is less than 0. So that's going to look something like this, okay? If you look at my graph, that's pretty close, don't you think? And I guessed. Okay, so I'm going to draw my axes. I should probably find my y-intercept. Oh wait, we already have the y-intercept. That's silly. Okay, so I'm going to plot my 2 points. Make this 1, so this will be 1.5. And I am going to draw my parabola. So it crosses through, and then it's going to fall. Okay, and then if we look on Desmos, we have just about the same solution. Okay. All right, according to the rational root theorem, which is not a possible solution of the equation? Well, let's identify this is my Q. Oops, there's my pencil. Q, and there's my P. So we're going to have 7 over 2. And the factors of 7 are 1 and 7. And the factors of 2 are 1 and 2. Two very nice prime numbers. Okay, so that gives me the options of plus or minus 1, plus or minus 7. So we got 1 out of the way. And oops, just a habit that I write plus or minus, but you don't have to there. If anyone wants to tell me why, I'll be very excited for that solution. Plus or minus 1/2, and then plus or minus 7 over 2. Okay. All right, well, I do notice that 3.5 is in our list. That would be 7 over 2, so we can go ahead and cross that out. We also see, I'm gonna do this in green. I like green. We also see that 0.5 is an option, so that can go away. We see that 7 is an option, that can go away. 2 is not an option, so we are good to go. Find all the real zeros of the function. All right. So, again, let's go for rational root theorem. So this is going to be my Q. This is going to be my P. This is going to be P over Q, which is the same thing as 48 over 3. Okay, and that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. These are all the factors, meaning that I can multiply a combination of these, and they will yield 48. Then we have 8, then we have plus or minus 12. 3 is pretty easy because 3 is one of my very favorite prime numbers. Plus or minus 1, plus or minus 3. Again, being silly about it, don't have to do that. And that gives me all of my possible solutions as plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12. Got rid of the 1, and now let's do the 3. Plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. Notice I didn't include 3/3. That's because we've already included it here. 3/3 simplifies to 1, so I'm not going to include it. Then we've got plus or minus 8/3, plus or minus 12/3, which I don't need to include because that's just 4. And that's it. We are done with our 3's. Okay? Well, I know from graphing it on Desmos, which you'll be allowed to do, is that I'm going to check x equals 1/3. Okay? And I'm going to go ahead and in order to not break my brain with some synthetic division, I'm going to say multiply by 3 equals 1 and add 1. So this, or subtract 1, so minus 1 equals 0. Okay? I'm going to go ahead and do some long division for this one. So 3x to the 4th. It can be done with synthetic, but I don't like using fractions within synthetic division. But if you are comfortable with your fractions, please be my guest to try it out. See if you can do it. Okay, so this is going to be 3x minus 1. Okay, well, this can go in x to the 3rd amount of times. This would be 3x to the 4th minus x to the 3rd. Okay. That cancels, and then we're going to end up with 12x to the 3rd, bring down my negative 40x squared. Okay. That is going, this shouldn't be a negative. That's crazy. There we go. That we can multiply by 4x squared, so plus 4x squared, so that's 12x to the 3rd minus 4x squared. Those cancel. And then this is going to be negative 36x squared, bring down my negative 132. Okay, I'm going to multiply by negative 12x, so that's negative 36x squared plus 12x. We get a nice positive value now. And then I forgot to bring my x down with my negative 132. I just wrote that in real quick. Those are going to cancel, and then I'm going to end up with negative 144x, and I'm going to bring down my 48. Okay, it's going to be plus 48, and I'm going to finish it off by multiplying by negative 48. So this is going to be negative 144x plus 48. Parentheses, close my line, goodbye, goodbye, remainder of 0. All right, so this is a root here, which is very nice, okay? I'm going to go ahead and simplify these. So I'm going to resize, make it just a little smaller and put this over here, okay? And then this is going to say, okay, well that means that 3x minus 1 times x to the 3rd plus 4x squared minus 12x minus 48 is equal to f of x. So that's my original function, okay? And now I'm going to see, can I factor this one, okay? Is this piece here factorable? Well, I'm going to go ahead and split it down the middle and see what happens. So we have 3x minus 1. I can take an x squared out of this side. This leaves me with, on the left-hand side, this leaves me with an x plus 4, okay? And then on the right-hand side, I can take a negative 12 out. So this is going to leave me with an x minus 4, or x plus 4. Okay. Now I can go ahead and rewrite it as 3x minus 1, x plus 4, because these are the same. And that leaves me with an x squared minus 12, okay, equals f of x, okay? Well, if we set each of these terms equal to 0, okay, that means that we have our 3x minus 1 equals 0, which we know that one was 1/3, right? So that's this one. Let's deal with this one. X plus 4 equals 0. That one's going to be x equals negative 4. I like that solution as well. And let's try this one. This one is going to be x squared minus 12 equals 0. I'm going to solve this one by square roots. So I'm going to add 12 to the other side. I'm going to take the square root of both sides. And I'm going to simplify this radical. So remember, this is going to be plus or minus. This is going to be 2, or let's do 3 and 4. So 4 times 3, okay, which is going to be plus or minus root 4 and root 3, which is going to be plus or minus 2 root 3. So we really have three solutions. We have x equals 1/3, negative 2 root 3, and positive 2 root 3. And if you look on Desmos, you'll see you'll get 2 root 3 is a decimal form. So that means that they just plugged 2 root 3 into the calculator and it spit out a decimal. Same thing for the negative and the 1/3. Okay. I do know though from some algebra that we definitely talked about, and I'm not quoting the theorem or the laws or fundamental theorems and stuff like that for a reason, because I'm going to have you look for that one. But I know that if this has a degree of 4, we're going to have at most three intercepts, right? So this is what that function kind of looks like if you blow it up really big. And then if you draw your x-axis, and your y-axis can go anywhere really, you notice that you have 4 possible solutions here. My bad, you have 4 possible solutions. We've only found 3. So that's leading me to believe that maybe, and we'll find another way to check this in class together, somewhere around our final date. So maybe there is a complex or imaginary solution that we haven't found yet. So we're going to talk about that one later. All right, use the information to answer the questions. So what are the real zeros? So we have one here, we have one here, right? So that means that we have 1, 2, 3, 4, 5. So we have negative 5, comma 0, or we can write that as x equals negative 5. And then we've got 0, 0, or x equals 0, right? Write an equation of the cubic function shown in factored form. Well, I notice that this has a multiplicity because it bounces, right? So this has a multiplicity of 2, or of any really even value. So I'm going to guess 2 because 2 is the smallest even number I can come up with right now. Right? Well, that is in the natural set. So I'm going to write f of x equals, well, my first 0 is at x minus 5, right? So if I do x equals negative 5, so that would be x plus 5 equals 0. And I also have a multiplicity of 2, so that means I have 2x equals 0 going on, which can be rewritten as x squared, right? So I'm going to write this out. I'm going to do x times x minus, or x plus 5. Another way that I would accept this solution in its factored form is, let's say you didn't write them all as linear factors, linear meaning like if I just graph each individual term here, it would create a straight line, basically. Because x squared is not linear, I would also accept this as an answer, okay? Oops. There we go. All right, fundamental theorem of algebra, find all the zeros of the polynomial function. So this one is exactly like we were just talking about, okay? This one is to find all the zeros. So we're going to use rational root theorem. This is my Q, this is my P. So this is going to be 49 over 1. That's going to be plus or minus 1, plus or minus 7, and plus or minus 49, all over 1, right? And then, so that gives me the possibilities of plus or minus 1, plus or minus 7, and plus or minus 49, right? And using Desmos, I'm going to choose to try, that way we don't have to try all of them. I'm going to choose x equals 7, and then I'm also going to try negative 7. Okay? So I'm going to choose plus or minus 7, basically. Okay? And so, yes, Desmos can give you all the answers, right? However, I just want to be able to see that you can synthetically divide. That's what's important to me. So this is going to be 1, negative 48, negative 49. Drop this down, negative 7, okay? This is going to give me negative, oh, I forgot a placeholder. That's my bad. Placeholder because this goes from a fourth to a second. We're missing the third power. So this is going to be 0, negative 48, negative 49. So this is going to be negative 7, 49, 1. Oops. There we go. And then, oh, I forgot another placeholder. There's a 0 here. I was like, why isn't this working out? It looks so nice. There we go. Negative 7, 49. Now we have a 0, okay? Now I'm going to use that trick I learned last time where I just kept factoring, because I'm going to show you that 7 is also a factor by just dividing it from here. So we've got 1, 7, 0, 0, 1, 7. I get 0 as a remainder. So 7 is a factor and negative 7 is also a factor. Okay. Same thing here. This is going to be a 4. So this is my P and this is my Q. So we've got 4/5 plus or minus 1, plus or minus 2, plus or minus 4, all over plus or minus 1 and plus or minus 5. Okay, so that gives me the options: plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1/5, plus or minus 2/5, and plus or minus 4/5, okay? We're gonna go ahead and try those out. Remember, use Desmos, figure out which ones you're gonna try, and then we'll do these together. So I'm actually gonna choose a fraction. I know, crazy. So choose x equals negative 1/5. Okay, that's what Desmos told me to try. And I'm going to use synthetic division here to show you that it is possible to do with synthetic division. So this is going to be negative 5, 9, negative 18, negative 4. I'm going to double check for placeholders. Nope, don't need them right now. I'm going to drop my 5, so I have negative 5. This is going to be 1, 10, negative 2, negative 20, 4, 0. And so that is a factor. Okay. Exercise 5, write a polynomial function of least degree with rational coefficients, so it can be like a fraction, okay, and a leading coefficient of 1. So remember, we're going to have like f of x equals 1, x to the nth power plus blah, 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 all the way until we get to our constant term, okay? All right, so this means that we had x equals negative 4, x equals 1, and x equals 7, okay? That means that we had x plus 4 equals 0. We had x minus 1 equals 0. And then we had x plus 7, or sorry, minus 7 equals 0, okay? Well, that's the same thing. If I write my function, I can come up with a leading coefficient of 1, so I'm not even going to write anything in there. I'm just going to secret 1. X plus 4, x minus 1, and x minus 7. We practiced this in our project. And there's a million polynomials that could have these solutions, but we've just come up with the easiest one, basically. Okay? All right, so for this one, we have a couple rules, and I'm going to go ahead and erase these lines so that I have more room to write in, but we're going to do number 2, because I believe we did number 1 in class. If not, number 2 is the only one that you have to do, okay? So this one, right, we have one thing. We need to identify x-intercepts. Okay, and then we need the points of the local maximum and minimum. So local max slash min, okay? And then we're gonna determine the intervals for increasing, decreasing, increasing slash decreasing, okay? And then we're gonna determine whether the function is even, odd, or neither. So what that means, okay, so even functions say that the original function is equal to, I wanna say f of negative x. So it's equal to being reflected across the y-axis, okay? An odd function is where the reflection across the y is equal to the reflection across the x-axis, and neither just means that it's not even or odd. It's just something completely different, okay? All right. So let's go ahead and finish this one up. This is our last problem, I think. Let me see. Oh, it's close to the last problem. Not quite. Oh, wait, no, we're not doing this one. That's my bad. I wanted to do the other one that we had planned. But we're still going to use all of these rules, okay? Right here. That's what I was looking for. Okay, so step 1 is we need to determine the x-intercepts. So we can start to do that. So 0 equals x cubed minus 2x. I'm going to choose factoring here instead of rational root theorem. I think that would be quite nice. So 0 equals x squared minus 2. And now I'm going to go ahead and set each of the factors equal to 0. And then I'm going to solve. So this is x equals plus or minus the square root of 2. Now the square root of 2 is like approximately like 1.4 something, 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 right? So I am going to go ahead and graph that the best that I can. So here's my axes. And I'm going to say that I go 1, 2, 3, 4. I'm going to say that this is 1, 2, that this is 1. 1, 2, this is negative 1. There we go. Okay. And I'm going to plot my points. So I have a solution at 0, 0. I have a solution at negative root 2 over 2 and positive root 2 over 2. Okay. Oops. Right about here. That's where that needed to go. Okay. And then I should probably think about, what's my leading coefficient, right? My leading coefficient is positive, right? So it's greater than 0. And my degree is odd, right? And I should clarify, even odd does not mean even odd like how 2 and 3 are even and odd. So 2 is even, 3 is odd, right? I don't want you to think like that for this. It might be that they're the same, it might not mean that they're the same, I just don't want to get the confusion there, that's all. So I know that this is going to probably look something like that. So that's going to help me graph, okay? And I'm going to go ahead and use Desmos to help me see the increasing and decreasing values, okay? So, but I also can kind of sketch my graph, and it's going to look something like this. And I'm going to call this maximum at point A, comma, f of A. And I'm going to call this one at point B, f of B, because I don't want to write decimals. I don't want to do anything. I'm just going to guess, okay? Well, it's not guessing if I give them fun little names. Okay, so for number 2, we need local min and max. So we have a minimum, and it's not a global, it's a local, so we have a minimum at the point a f of a. Okay, let me see, does it specify if it wants points? Yeah, gives me points, awesome. And then I have, oops, this is a maximum, that is my bad. And then this is a minimum at b, f of b, okay? 3 is I want to find increasing, decreasing intervals. Well, I know that I'm increasing on this interval from here to here. And use an open circle to represent that, okay? It's a calculus issue though, if we want to use closed brackets, but I'm gonna use open brackets. And it can go that way forever, right? So I am increasing on the interval of negative infinity all the way until I get to somewhere where a is, right? I'm also increasing when I start at b, right? And then I go back to an increasing value for a really, really, really long time, right? Think of it like money. You want upward trends or positive slopes, right? So I'm increasing from b to positive infinity. So let's write that one down, okay? That is going to be negative infinity to a, open brackets for all of them, union b to positive infinity. Let's do decreasing now. Decreasing, I'm from a to b. Okay, so that is going to be from a to b. Okay, let's talk even and odd. I'm going to put even and odd down here. When I do even and odd functions, or neither, I test everything. So I'm going to write my original function here, and that is x cubed minus 2x. And we are going to find the reflection across the x-axis and y-axis. So this here, I'm going to write this in maybe green. This is our function transformation of reflection across the y-axis, and this is a reflection across the x. Okay, so let's find both of those, yeah? So let's find f of negative x, okay? That is going to be, I'm going to put parentheses, and I'm going to replace every x that I see with a negative x. Okay? So this is negative 1 cubed is negative 1, and x cubed is x cubed. Negative times a negative is a positive. Okay? So I'm going to write that in here, negative x cubed plus 2x. Okay? Now we're going to go ahead and test my reflection across the x-axis. Okay? So negative f of x. So negative, and then my entire original function, okay? And I'm going to go ahead and distribute. So this is going to be negative x cubed plus 2x. I'm going to write this down here. Negative x cubed plus 2x. Well, that leaves me, right, f of x is not equal to f of negative x. So it is not even, right? So let's go ahead and try our odds. So this would be f of negative x needs to be equal to negative f of x. And that is true. So it is an odd function.